Work. All of us use the term work in our daily lives. For example, a crane lifting goods to a height, a weightlifter standing still while holding a barbell above his head, and a ball rolling with constant speed over a smooth ice surface are all usually considered examples of work. In general, work seems to be done in all these activities. Interestingly, in physics, not all these activities can be considered as work done. Let us try to understand this paradox through this animation. Watch these workers. As long as they are pushing the sack cart, we see that there is a definite displacement of the cart in the direction of the force they are exerting. But when a person is standing with a heavy sack on his head, the sack is not being displaced. In both these cases, whether the sack is being displaced or not, the workers seem to be doing some work as they are using energy. However, in terms of physics, no work is done by the person in the second case as long as he is standing in one place and holding the sack. Why doesn't physics consider his efforts as work? Let us understand the concept of work from the viewpoint of physics. In general, work done is defined as the dot product or scalar product of the force applied and the displacement produced in the object. Work done is expressed by the formula W is equal to F dot D. Resolving the dot product, we obtain W is equal to F cos theta times D. Here, theta is the angle between the force vector and the displacement vector. Remember that work is a scalar quantity even though it is the product of two vector quantities. Note that in this example, the angle theta is equal to 0 and hence cos theta is equal to 1 as the force acts in the same direction as the displacement produced. Work is measured in units of joules. 1 joule of work is said to be done when a force of 1 Newton pushes an object through a distance of 1 meter in the direction of the force. Let us now get back to the workers pushing the sack cart. Let us say that they push the cart with a force of 50 Newton through a displacement of 10 meters. So, the workers do a work of 50 Newton times 10 meters, that is 500 joules. Now when the other worker is standing with the sack on his head, there is no displacement produced in the sack. Even though a force F is applied by the worker to hold the sack, no work is done in terms of physics as the displacement produced is 0. Now let us go back to the everyday examples of work done and check if those activities can be called work from the viewpoint of physics. In the case of the crane lifting goods from the ground to a certain height, work is said to be done because a non-zero force applied by the crane picks up the goods through a non-zero displacement. But what about the weightlifter holding the barbell? Technically, no work is done here as there is zero displacement of the barbell even though a non-zero force is applied by the weightlifter. Similarly, take the case of the ball moving on a perfectly smooth horizontal surface of ice. Here, there is no force acting on the ball as we neglect all frictional forces. So, we conclude that the work done in this case is 0 as there is no force in action.